Hello and welcome back to compiler programming. Now that we have a rough definition of the syntax of the language, it's time to get back to tokenization and some preparation for it. Right now we have this create is character set checker function, which is nice and allows us to quickly create this type of function that goes from a code point to Boolean saying, okay, does this belong to a certain kind of character or not? But if you look at how it is written, this is usually not how you would write this function. Usually you would, if you are writing C, you would do something like bool is white space here 32 code point, and you just say code point is turn code point is /n or code point is something else. Basically you just separate it with the logical OR operator. And we don't really have logical OR or logical AND. And while they may seem quite straightforward, they are actually a bit tricky. And the reason they are a bit tricky is because they are short-circuiting. What does it mean? Well, it means that, for example, for OR, if we have, if this condition is true, then this condition is not evaluated. And the same for AND, but in reverse. Like if this condition is false, this part is not evaluated. In this case, it's not really that important, but especially if you have some function here, like it will not be called. And this is kind of important thing to keep in mind, which actually means that, for example, you can't do these comparisons in parallel. This is not a semantic of the compiler, and but on the other hand, it can be nice in case each one of them is actually a heavy operation, so that you can not do it. And in the extreme case of extreme optimization, like if you're writing something like a tokenizer and you want to go for it to go really fast, I mean, you wouldn't use the function in the first place, but if you do use a function like this, then you can start playing around with the order of the things you can pair, and that way, like if one of the first conditions is the most likely one, then none of these will be evaluated and you save some instructions. So just something to think about. Anyhow, for us, the most important thing is this AND and OR. We don't have the operators for this right now, and would be nice if we did. So how would that look like? Let's actually go probably in here and start looking at this. So we say should support AND. Actually, I would be more explicit, say should support short circuiting, and we will need to figure out how to test that. I guess what would need to happen is we would get an argument that is S8, so something like what I prepared here in Firefox. So this is how it looks like. We test the value. I mean, if we have something else here, it would be not test, but it would be basically this is the result of a compare. Let's say I do this 32a is less than 0, something like this, or hint a. Yeah, so less than 42. I can't use 0 because it just does test instead of what it should be doing. So yeah, it does comparison, and then you would you have a jump for the inverse condition, right? So basically, if we do the comparison, and if it is greater, so the condition is false, we skip this branch, this B, and we go directly to here, to the exit of the function. So in a sense, the resulting code actually does look like what we were doing here, and this is why I wrote it this way, right? Because this is what we have. We have compare and then return, which is exactly what we have here with the jump to the end of the function. So here is what we want to do. Let's try to figure out how we're gonna do that. Well, let's replicate this test function and check if that it works correctly. So arg s32a and then arg s8. I'm not sure if we actually have a helper like this, but we should add it. Bool is s8 basically, just a reminder. So let's have number and I don't know, condition. And then we do what? We say return less number value from s3242, and let me make it a bit more readable. We say end, and it will take two things, and we say condition. Okay, obviously we don't have end right now at all, and I'm not even sure we have less, so let me add a mark over here, and then we can jump. Basically I need to search for less. Yeah, we don't have that. It's not in spec anyway. So we do have less. Good. But we definitely don't have end. And we need to figure out how that would look like, because the general issue is that this is optimized code. I guess I should change it to be unoptimized and see what that looks like, because that will be closer to what we can actually implement. Let's see. So this stuff we will compare with x42, and then if it's more than that, it jumps to saying that it will be 0, and then that 0 is put into the result. So it looks like the way it works is it creates a temporary kind of result of that Boolean expression. Then it evaluates one of them, and if it is false, it jumps to it just puts 0 in the result of that expression. Otherwise, it loads the result. I'm not sure what move that x actually does, so let me check that. Move that x. Move with 0 extent. Well, that's actually a very useful instruction that I didn't know existed, which is what we want to use at some point as well. Okay, makes sense. It loads into EAX the value, and so like 0 extends it to the full width. Then it tests it, and then if it is equal, then it jumps to here. So it's basically, if it is 0, this is more or less JZ actually. They have the same code, so it's slightly awkward. And then if it is not, it says that it is this one, and jumps to the return value. Okay. That probably makes sense. Let's try to figure this out. So yeah, this is what we want to have in the end, but for now we will remove it. And what I will do actually is I will have it like so. So I would say value star less is this, and condition is already a value, so we don't need to create it. We remove this star. Then we say value star result is end of less and condition, and return result. So let's get rid of this stuff. But let's figure out what end actually should look like. Well, again, let's just look at this as a source of inspiration. We will need to have some way to store this intermediary, like the result of the expression. Let's reserve some stack for it. We say value star and result. Actually, the result is fine. Reserve stack of builder and descriptor as h. Yep, that sounds good. Then we do the compares. Actually, this should happen before the end, which is not really how our stuff works, right? Because well, I guess that's fine. That is fine. We'll use the same trick as we use in if, where we do comparison with 0 instead of directly using the result of compare, which is more efficient, but not how we have it implemented at the moment. Okay. So it actually does need to go into here. Say result, then we say if what? If result. We need a label. So label star label is make label. Right, and we don't know where it will jump because it will jump somewhere over here after the condition. Okay, so if result, then what? We are looking at and. That means that we actually need if not result. So this is, I don't believe this is something that we have at the moment, and something we will need to add. So let's start with that, not ic. We could just do general not, but I think having not equals is also good because it's more efficient to have it that way, and also it probably will be easy for us to implement. So we just say case compare not equal. We move it after equal, so it is more easy for us to deal with it. And I guess it would be set what? Set cc and e set byte if not equal. So this is what we need to add. I guess we'll need the instruction stuff as well. Let's search for set z. Good. Set L, set G, let's copy one of them. We say that it's called set and E. Let's create this, this, here and here. Now we have set and E, it's 0F95. Okay, sounds good. We can use set NE here. Okay, now we can continue. We say not eq result 0. This will be a very, very inefficient implementation of AND and OR, but right now we want to get the semantics down first, so that's fine. Okay, so if it is not 0, let me get back to this thing. So if it is true, that will be 1. So if it is, actually we can compare it with 1 directly, I guess, but not equal 0 is also fine. Okay, not equal result 0. So it is true, then we continue. Actually, this should be like this. We don't need that not equal because we only wanted to check for false. So for 0, that means that actually it is equal 0. Yeah, whatever. We added some stuff. That's good. If it is equal, then we do what? Well, we jump to the label. Okay, builder. Already forgot how our instruction looks like. So let's copy this stuff. Okay, we have instruction, and then we have jump to label 32 of label. Actually, we also need to update. Yeah, let's update the result right away. So we say move value result. Actually, it shouldn't be a result. It should be less here. We say move value result value. It's a builder. Value from S8 of 0. Okay, that's good. So this 0, we say that the result, the whole expression is 0, and we jump to the end. If it is not 0, then we say that what? Well, again, we need to compare the so then we the result of the second expression will be basically the result of the whole expression, right? So if this is true, then if this is true, then the whole result is true. If this is false, then the whole result is false. That means that we say that move. Well, we don't even need move value. We can just use the result of ik as. So we say ik result is our final result. But we have thing here, so yeah, I guess we will need to do this. Okay, so this is the other branch of this. Okay, and after that, we do need to add a label. So we have this, maybe label is label. So this is where we jump to, I guess, right? So this is the end of these two things. Okay. Let's see what happens. First, let's try to build this. Compare not equal undeclared identifier. Yeah, I added it here, but I forgot to add it over here. And actually, let's start with this stuff so we don't accidentally do something by default. arg s8 is undefined. That is fine. As I said, we should just add this because it will be useful for us later. We might even consider adding another alias. Will be just argbool, which is exactly the same as s8, but for now that's fine. Oops. Condition, local variable changed but not referenced. Yeah, it shouldn't be, result should be condition here. Okay, encode undefined and assuming, yeah, it's should be push instruction, I guess. Okay, so let's open up our dev environment and see what we have so far. Are we in the right file? Yes, it is function spec, but we don't want Fibonacci anymore. We want to go to the top and look at this stuff. Oh, okay. We do have the function, but we don't really have it's done so that we can call it. Valid function. Function type will be S8 or S32 S8 to S8. Right, and we probably don't have this function yet specified, so we'll also need to add this to here. But we don't even have any S8 functions. This is funky. Well, need to start with something, I guess. S8 star function type, and S32 S8. Okay, maybe I should create a macro for this. I don't know. I'll think about it. Good. Let's build this again. Checker to few arguments per call. That's fine. Let's say that we pass in 52 and then true. So, and basically, we can, since this is supposed to return a boolean, we can just do it like this. So let's just check what is expected output. If we pass 42 and true, we expect to get false, right? Because the first condition is false and the second condition doesn't matter even if it's true. If we pass 32 and false, we expect also false because the second part is false. If we pass 32 and true, then this is expected to be true. Okay, we have our stuff. We are building correctly and we are ready to try this out. Okay, B was null pointer. That is interesting. Where did they pass a null pointer? Oh, okay. And that is actually correct. I passed 0 instead of immediate 0. So that's on me. Good. Let's try that again. Did not find an acceptable encoding for move R8 M8. Okay. This we probably can fix. Where is our move, which is the restart and probably the most gigantic one. So yeah, we have RM8 immediate 8, but we don't have the version that is supposed to go into here. And I bet it's going to be 8A, but I will check in a moment if that's actually correct. Or no, we want other way around, right? We want actually, let's just add both. This is probably 88, RM8, and R16. Okay. Move. Okay, so for 88, I was right. This is the one that we want. And then 8A is also correct. Good. We are still building. Let's try again. Ah, okay, I was looking at the wrong instruction, I guess. Oh no, it was move. Now it is compare. So we have compare, 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 compare. Well, we have RM8 and immediate 8, but we indeed don't have, what was it? Yeah, R8 and M8. That's fine. Let's do compare. RM8 and R8. This is the one. This is going to be 38. 38. RM8 and R8. And other way around, while we are here, is 3A. So this one we actually do have. While we're here, let's just, it's not R9, this is R8. So 39, 39, 39. I'm just adding this version as well. And this is 16, 16, 32, 32, and 64, 64. Okay, we are building just fine. Let's see how we are. Okay, at least we got to the right place, but I still don't know if the actual implementation of the function is correct. So here we go. What do we have? Well, we load 42 into some location. We do this, we do compare. And then we say if it is lower, then it is going to be true. I can, oops, let me make this slightly smaller. So I want in watch to look at RSP plus 14, I guess. No, plus 13. This is where the... So it is false, which is probably correct, because if I say, what is it? We are doing ECX, right? Yeah, so it is correct that 52 is not less than 42. So this is good. The question is what happens afterwards. We save it. We compare with 11. That's fine. We store it. We compare it again. This is very unoptimized, but as long as it works fine, we are fine. So we say if it is 0, it should be 0. So I expect us to jump to here directly. Yeah. Is it correct though? Wait a second. So we jumped over what? We jumped over these 3 values. So if equal less than 0, yeah, it probably is actually incorrect. Yeah, we should have jumped to here if everything was fine. So let's just let's play through, and yes, our tests are actually failing. So it doesn't do the right thing, and it actually fails for 32 and false. Because here we actually want the not equal, right? Because it's an AND, and we want, if it is not equal to 0, then it is truthy, basically. Okay, what if I run the tests again? We are still failing, but now we are failing. Yeah, now we are failing in the place where I would expect us to fail. So did I mess up something with the logic, or is it a mess up in our encoding? So first, let's walk through what we are doing. We are saying that the output of the whole AND will go into here. It will be the result, this one. If if the result is false of the first part, so if this is false, then we skip the B and we should jump to here. Where we resolve the label. So maybe I should do the inverse part here, and it will be easier code. So let's try to look at what will be if we do this. So if it is not 0, then we say that, so basically we can do it like this then, right? So if it is true, we will need to compare the second thing is true, and the result will be the second thing. So this stuff will work just fine. And then we will need to jump. Otherwise, we say that result is false, and we jump to here. Okay, let's try in this configuration. Test. Still fails. So something is not working like I would want it to work, or I'm missing something fundamental about this. So where does it fail? Checker, not checker, 32, 0. So let's just walk through what we think this code will do. The number is 32. Okay. Is it less than 42? Yes, it is less than 42. So we go into this code. Here we check if the second argument is not equal to 0. Okay. Is it not equal to 0? Well, it should be false. So should this be equal to 0? No, it's not equal to 0, so the result is 0, and the 0 should be put into the result. And then we say that we want to jump to here. Sounds fine to me. So I guess it's assembly debugging time. Okay, again, this is 42, blah, blah, blah. This is less. This is not very interesting. And now we are coming to if. So this is where if starts. Just to show, like, this is, I guess I will switch these things around to maybe make this stuff smaller. Okay, so this instruction here is this here. We are comparing this with 0, and if it is 0, we will skip the whole thing. So this 5a is all the way over here. Okay. And this 5a does what? It puts the so this is return, move al byte tr, whatever. And then jump, which doesn't do anything, and rsp, whatever. So okay, this is a return, and this is us putting 0 into, wait a second. Yeah, okay. Yeah, so if this is if, then this is sort of else, which is this move, and this is the label, so the other jump should be to here. Yeah, the logic so far seems sound to me. maybe I screwed up somewhere with instructions themselves, but yeah. We have ECX and we have ETX, or actually TL. Yeah. Okay. So the input is 52 and 1. The result should be false, and I think it is false, but let's look at how it looks like. We go to here, we should jump straight to this instruction. And we do. We say that we put it in the result. We put it in here. Let's add AL because this is our, let me get rid of some of this stuff. Okay, so everything is fine. Now I will add a second breakpoint over here. We go like this and go inside again. Okay, this is the thing that actually fails. It is 32 and 0. We compare it with 42. It should be true that it is less than 42. So we should not take this jump. We should go inside. We do go inside. And then we have, we load one of the operands, which is fine. So AL now is 32. No, now it's 0. Okay. We compare 0 and 0. If they are not the same, then we do what exactly? Okay, we move it into AL, and then we move it into RSP12H. So AL says that it is true. Wait a second. DL was 0. And then, so we are taking 0. We are loading DL into AL. And then we are comparing. Oh, I think this is wrong. And like this comparison is correct, but this comparison is actually wrong because we are always using 32-bit value over here, and it shouldn't be 32-bit. So I guess this is our issue. Where is this stuff again? Compare, come to me, and let me know what's wrong. So condition, let's just check everything. Let's start with the arg stuff. Okay, so arg S8 has the correct descriptor. Good. So condition should have the right stuff. Second thing is we are comparing condition and value from S8. This should also be fine. Where does that 32-bit come from though? I'm a bit confused about that. So what do we do when we do compare? So this is our not equal, it is compare not equal AB. And we say reserve stack for the right size. I believe that one actually does work because we have a byte. Let me look at this code again. So what is happening over here? We move 0 to a stack location, which is what happens here. I believe it is this line. Then we move to register, which is here. I think I screwed up somewhere over here. Yep. This is the issue. I have screwed up the actual lookup table. And this is why I want it. I want to generate it usually. Okay. Let's try this. Let's try this. Following breakpoint can't be set. Whoa. Let's try it again. Okay, looks like it does work now. Cool. So this is our end. The only thing left now is turn it into a macro, and I will not show the OR because OR will be sort of the exact opposite of that. You just compare more or less with 1 instead of 0 and like inverse the whole condition, but the flow will be exactly the same, so it's not very interesting. Okay, but we do need to figure out how to make these into a macro. Let's take a look. So define, and let me add a bit of stuff at the bottom so it is easier to follow. We have A and B, and I think we will. Do I need a for loop? Yeah, I guess I do. And no, we will have a helper that will be make and builder A and B, like so. And we say, what does it return? It returns a value star, make and value star A, value star B, and this is what we do. You also need function builder. We replace this stuff with it. And it will start looking good. So obviously we don't have less, we have A, and then we have B over here. And the rest is actually should be correct. You can think about how to optimize this, but as long as it works, it is gonna be fine. Good. Let's not remove this code until we know it works. We try this. Can move this into here actually and see what is going on. Builder undeclared identifier. Oh, because this should be if builder A. I think that's gonna be like that. Move value. Yeah, not equal is isn't very happy with us, but we can just call directly and the right thing, and that would be also fine. So we value star right hand side is this. Compare builder not equal B and value from a state of 0, and then we say move value result right hand side. That's fine, but we don't return anything, and we should return result. Good. It builds. Let's check if it works. It does work. Everything is fine, and we now have end, which is great. So it's good to add useful features. Good. That will be all for today. I thank you very much for watching, and see you next time.